So my name is Coltran Hophan-Nichols. I am the Director of Systems and Research Computing for Montana State University. And I'll be talking about the journey we went through on running our own local LLM and generative AI service. I can see from our kind of catchy title, we initially did this without a budget. And we wound up branding our service Cat Chat after our campus mascot. So why did we do this? We really had a need on campus that I think is becoming more and more common, where we needed to provide a service that was pretty broadly accessible, was feature rich, secure for university data and compliance reasons, and provided an AI platform that could be used across teaching, research, and administration. We started by looking at some of the free commercial offerings. While they worked for some use cases, they really didn't have the needed level of feature and flexibility for what we were looking for. And looking at some of the paid commercial tools, if we were to license them for all of our faculty, staff, and students, that would have been almost our entire software budget for the university, so not really feasible for us. And in addition to the fiscal sustainability, we also cared about environmental sustainability of a solution that we're going to have broadly used by our student body. So that led us to take a little bit of a step back and look at building something ourselves and leveraging open source technology. Now, the platform I'm going to be talking about, we don't see this as everything for everyone in terms of AI. We really see it as part of a more comprehensive and flexible AI ecosystem. So the pyramid here kind of represents this. At the top, we have those paid commercial AI subscriptions. We have a number of those, some of the major leading vendors, where we've been able to put in place agreements with them, have those available in a way that works with our data use policies for the university. And we have those available for purchase by faculty, staff, members who really need them. So, for example, someone who's working really heavily in a productivity sense and is looking for something that integrates with the Microsoft Office suite, they might want the paid version of Copilot, for example. On the next step down, we do also provide some of those free commercial offerings. This one was a little bit trickier in that a lot of the free commercial offerings we weren't able to necessarily get agreements with to fully meet our data security requirements and data privacy requirements. The one we were able to get in place here is Microsoft Copilot, the free version. Since we're a Microsoft shop, that falls under the data use agreements we already have with Microsoft for M365. But then really the missing piece that we had was the foundation of this foundation of this pyramid. And for that, that's where we really went with an open source platform that's running locally to provide that broadly accessible and more feature-rich solution that can be really used for things like teaching advanced agentic concepts in a class, etc. So this is the high level of the platform that we went with. So we didn't build this all from scratch. We leveraged some pretty commonly used open source tools. So for the front end, we have a web interface as well as an application interface that is pretty highly customizable, provides a number of chat tools with different integrations, custom agents, custom knowledge bases, and a number of pretty kind of advanced or custom features that can be really useful. One of those we've seen really good feedback on from the academic side is the thought process or mind map aspect that allows you to really dive down into what the process is that a model is taking to get to the result it's providing you. This can also provide you a confidence rating in terms of how confident is the model that it's providing you the answer, a correct or relevant answer. And then on the API side, we have an API interface that allows integrating with generative coding integrating for generative coding assistance within various IDEs. This can also be used for pretty much any programmatic application of generative AI. So we're seeing this used with high-performance computing workloads that are already running on our cluster, where people are integrating in where they make API calls into this platform in such a way that they can leverage generative AI as part of a larger computational workflow. This is compatible with pretty much any open API endpoint, and also can be used to tie in with custom agentic applications or trusted compute environments. The image on this screen shows you a little bit of the high-level architecture that we have. So the front end of all of this is running in VMware. It basically has our Open Web UI, which is our web interface, as well as our Light LLM, which is an API interface. And then the compute portion of this is running on our existing HPC cluster called Tempest. We're leveraging actually 840, A100, and H100 GPUs to run the actual compute for these models. So as I said, we're leveraging pretty much entirely existing resources right now, hence the being able to do this without a budget, at least initially. So the compute is all on our HPC cluster. The front end management, etc., is all within our existing virtual hosting environment. We use VMware in our shop. And then for storage, our models are stored in our HPC storage, and the VMware storage handles our database for chat history, user permissions, etc. This is all supported by our research cyber infrastructure team or research computing group. We have both staff and students working on this. And this is entirely local. It's all on-prem, running primarily with renewable energy and without significant water use. So we're checking a lot of the boxes we were looking for in the initial platform or initial goals. I'm not going to dive too much into the technical side for this one, but as I mentioned, we are running Open Web UI for our web interface. It's a pretty commonly used feature-rich platform. It is not fully open source. It is free to use, but there are some limitations where you have to purchase a license if you want some additional features, but they're generally not features that affect functionality. Our Light LLM is doing our proxy and API interface. Postgres SQL is our database. And then on the compute side, to manage and orchestrate our compute on our HPC cluster, we leverage two different platforms, vLLM and Ollama. The reason we're using two there is we wanted our major and commonly used models to be persistently loaded in such a way that users don't have a lag time for the model to spin up before they get a result back from a query. So our most commonly used sort of primary models are handled with vLLM and persistently loaded. And then we have a large set of different open source models that are very useful for maybe a specific domain, but not commonly used. And those are dynamically loaded based on demand and resource allocations as needed by Ollama. Our access control we use for the web interface, we use a standard campus SSO with multi-campus login. For us, that's Entra. And then our API interface is authenticated with API keys. We have a custom application that we developed that allows users to generate, to log in via SSO with multi-factor authentication, and then generate a time-limited API key. So they don't have to contact us each time they need a different API key. We are able to track and monitor those and their usage and tie them back to the individuals who generated them. This is the slightly more detailed technical architecture. Essentially, it's a VM running in VMware with a number of containers on it, network connection between that and our HPC cluster. And then we have a few GPU nodes that are persistently allocated to this service for those primary models, and then a number that can be dynamically allocated based on demand, so we can scale up and scale down to meet the needs of the service. These are the models that we're running and how we manage them. So our primary models that we statically load include OpenAI's GPT-OSS, Google's Gemma 4, and Qwen 3.5. And then for our dynamically loaded models, you can see a much longer list there. I'm not going to read through all of those, but we've actually added quite a few more since this. So this list has been expanding over time. We basically, almost any one at our university can contact us, request a new open source model be added, and we're generally able to do that outside of the very large models that require a huge amount of GPU compute to run. But in this way, we're able to meet a lot of those kind of use case specific needs for different fields. All right, so overall results for this, we've seen pretty rapidly growing adoption across the disciplines at our university. We're seeing a particularly good utilization of the custom agents being built out, including for classes where instructors are building an agent or model configuration that is really designed for how they want AI to be used in a given course. We've even seen some Claude Code users come over basically due to the fact that we don't have a token limitation. And so while the models we're running, the open source models, are not as accurate as Claude's models by any means, the fact that users can run as many queries against them and as many iterations as they need can often overcome that. As I said, we're often deploying new domain-specific models. We're seeing more and more integrations with different programmatic workflows, including some stream processing data and some enterprise uses. And then we've also recently added frontier models, so the flagship commercial models via Azure Foundry. You can do this either via Azure or AWS. They both support this, but we're basically able to tie in to the cloud models. And we don't provide that to all of our users, but certain administrative or enterprise use cases that really demand one of those commercial models can leverage this same platform. So that doesn't have the same environmental and local aspects, but it allows us to leverage cloud models and frontier models without having to jump to a different UI and platform. We've overall received really positive reception on this product, including with a number of users who tend to be a little bit more skeptical around AI and are maybe concerned around privacy and environmental impact. And we've overall achieved a pretty good reliability, but it's not yet enterprise class. So because this is reliant on our high performance computing infrastructure and the front end is not fully high availability, we aren't at our normal enterprise class level of reliability. So what I'll kind of end on here is what we're doing next. We've seen such rapid adoption of this that the university is really wanting to make this more of a enterprise class platform for us. And so over the course of this summer, we're doing work to move the front end, actually front end and back end to some extent, into a Kubernetes environment that'll be fully dual data center, high availability, achieve much higher reliability. We'll also be purchasing support for some of the key components, just so we have that backstop. And then we're also, while we're going to continue using HPC for a lot of the compute, we're going to have a small portion of compute outside of HPC that can keep the core part of the service, the primary models running, so that in the event that our HPC system is down, we don't bring our entire service down. We would have to limit it, but we'd keep it running. So that's kind of where we're at right now. And I think that maybe actually be a decent segue into the next presenter in terms of the platform that is implemented there. So I believe that is the end. With that, we'll take questions, I believe, after the next presentation. So thank you.
Yep, that sounds great. There was one question in the chat, but just heads up that we'll just hold until the end of the second presentation. Thank you. And then Johnathan, thank you for presenting today.
Yeah, hey, how's everybody doing?
Good.
Let me go ahead and get this shared. Find my window here.
Just thinking about it, I see it. There we go.
Cool. All right. Yeah, so how's that look for everybody?
Looks great. Yeah.
All right, so yeah, this I think talk will be a little bit different. I'm coming from I guess I'll introduce myself first. Jonathan Lee, Senior HPC System Architect with Arizona State University. I've been with ASU a little over 12 years now, actually about 12 and a half years now, and I've got to work on a lot of really cool and interesting projects over the years, but I feel like this is probably one of the coolest ones I've done. This AI project has been my life for probably the last year or so. And I'll kind of just give a little bit of an overview of what we have, because I don't think I covered that too much in the slides. But in general, we about 6 months ago or so, we ended up getting a donation of equipment that filled up an entire new data center space. So about 220 systems, where we had to limit about 3 systems per rack. You can kind of see in the background of this image there. That was one of the pictures of some of the equipment. But we got 80 racks worth of space now being used by these 200 or so some odd systems. So this is kind of what we built this platform on top of. So just hit next slide, see what I got here. So yeah, so why self-host? I guess the big one there is we got a lot of equipment. There was this big donation, and it kind of kicked off, this project in general. But some of the big, reasons why you would want to self-host would be, that the cost is kind of fixed. You have a set cost for your infrastructure hosting, and the tools that are running on top of it versus, users actually, hitting a cloud resource and burning credits. So another thing is the data locality. You got the always on endpoints, and yeah, just all the nice things that come with self-hosting equipment in general. So I'll try to move through these pretty quick too. I do realize I have probably more slides than I should for this, but for the time that's allotted. But yeah, so this is kind of our stack right now. We're running Kubernetes with K3s on Rancher across about 200 nodes. We're provisioning these nodes with Werewolf. So this gives us a nice base image for these systems. We do have some stateful things like with our Longhorn PVCs there. These are 7 TB NVMEs that are on these systems that store any data there that needs to be persistent. We're running VLLM for the most part across this infrastructure. Light LLM is currently our kind of AI gateway that we're using in production. And we're using HA proxy for kind of the inbound traffic sitting on top of Kubernetes there. Cloud native Postgres for our database. And we're using an in-house provisioning portal for self-service of keys and showing users their individual usage. This is kind of what it looks like right now. We have the chatbots on campus. We have, IDEs. Students, have their IDEs. We have things like our Slurm chat, which is a chatbot we've created for our Slurm cluster. Our regular just, people connecting in with the OpenAI API. That hits our HA proxy, and then we hit our gateway. I'll talk about this top part here in a few. It's a kind of a tool that I've been working on here for a little while. And we're currently using AI Bricks, which is a VLLM I guess project to do the actual routing to the individual models that are running VLLM on our dedicated hardware there. So one thing that I think really helps us, we have this kind of we already have this account management identity system that we've been working on the last year and a half or so. So this was kind of a nice place for us to be able to tie in, users being able to self-provision API keys. So one thing we wanted to make sure when we were doing this was that we didn't want to get throttled or bottlenecked or overwhelmed by the number of users requesting API keys. So we added this into the portal, and now users can actually come in and see their individual token usage, their keys, what models we have available. We have some other interesting things in there like benchmarks between the different models to help users decide what they should use. So that has been working really well. And this is kind of what the portal looks like. So this is a snapshot of what it would look like on the AI tab. You can see down at the bottom, we have, list of the models that are available. There's 26. It shows your top models that you used, your individual keys there, it gives you kind of a little quick getting started. So if you want to copy and paste something into your, command line there, you can actually, test some of these things relatively easy. So this one, I mean, everybody's probably aware of this. I think we touched on a little bit on the last talk, why Slurm isn't a greatest place, why your HPC equipment's not a great place to run some of this stuff. So I'll skip over this one here pretty quick. But in general, we want to dedicate hardware for this. We didn't want to, run this on our Slurm cluster. This is a, kind of an overview of the hardware we received. It's a little bit older. This is 3 to 4 year old hardware. It's mostly Supermicro and WeWin devices. So these are two different manufacturers that have created these 8-way Gaudi 2 systems. We have, limited power per rack and limited cooling per rack. So most of our racks in the data center have a maximum of 3 of these. As you can see in this one, this is in our Iron Mountain data center, which has a little bit better cooling. And we've put actually 5 in these racks here. We have 3 racks of 5, and that has worked okay. These also have a lot more power in those racks too. Yeah, there was definitely some downsides here. And I can share these slides out as well if anybody's interested in reading over these a little more. But, being Gaudi devices versus an NVIDIA device, we ran into some struggles with that, specifically around, software stack. Even with VLLM has done a pretty good job of keeping up on the Habana fork, or I guess the Habana plugin now for VLLM. But still, there's models that we can't run without significant tweaking. Initially, when we first spun this up, there was a lot of struggle around getting even basic models running on this hardware. Yeah, so we've also I put together. I have another project, Slurm Dash, that I also share out. This is kind of led me to creating something similar for our nodes here. So we have a nice little dashboard that ties into Kubernetes that is not currently public, but if anybody's interested in it, I could definitely share out the code for that. But it gives us kind of an insight into the actual node, like the node status across the board, which models are being used, number of requests per second, all the stuff that we would need to look at to see kind of what's going on the system. And this is kind of an overview of that dashboard there. You can see here in this picture, we have 178 nodes currently running and about 45% HPU allocation. Not saying that those are all currently being utilized, but we do have quite a few models up and running with a certain number of replicas across the board. So that's kind of where that 45% number comes from. And then you can see we're using quite a bit of power across those few nodes in that secondary data center that we've spun up. This is kind of the inference view. So you can see, when you have, number of incoming requests, tokens per second, all that fun stuff. So kind of the same sort of thing you would see like in Grafana. AI Bricks, for example, does export stuff into Grafana. So you can kind of see the same information there, but we wanted kind of a one-stop shop to see everything that we're looking at when we jump in to see how the system's looking utilization-wise and, when we're troubleshooting anything. We are running Rancher. So we have, these are the deployments that are running. You can see on the kind of right side there, the number of requested models versus the running models. You can see some of these are spinning, 10 out of 11 available. We have some auto-scaler policies running. So as a model gets more use, it'll actually spin up additional instances. So that has worked pretty well too. The only thing I would say is sometimes that has taken a lot of tweaking. Sometimes it's oversensitive, sometimes it's not sensitive enough. Again, with all this stuff that I have here, we have all this stuff in our internal Git, but if anybody's interested in seeing exactly how we spun up any of these things, we can definitely share that out as well. So like I mentioned before, we ran into a couple issues with LLM that we were still trying to work through. Mainly, we had, like, for example, we had one user a couple weeks ago who, doing actual work, spun up enough workload to completely saturate one of our models, one of our popular models. And the only way to really go in with LLM was to actually limit them based on a number of tokens or requests per minutes, but which then would have these weird spikes across the cluster. And we don't want to do that. We have this have this hardware available and we have a certain number of models, but even if we scaled this to 64 replicas of a model, and that user's code uses all 64 replicas of that, no matter, or if you bump it to 28, all of a sudden it's using all 128. There's not really a good way to get around that. Setting a hard limit on the tokens per minute or requests per minute, you kind of had these spikes. You would instantly spike full cluster usage, and then it would drop down because you'd hit your limit, and then it would spike, and then it would drop. So running to stuff like that. Also, a lot of these things, we have like locally hosted, everything's locally hosted that we're using through this. We're acting as a provider for campus. So we don't point to things like Claude or OpenAI's API for this. So we're running into issues with things like our Minimax model, which is very popular for coding, doesn't have like vision capabilities built in. So, trying to get that to work through here to say, if an image comes in, but this model doesn't have a vision capability, use this other model for the vision. We ran into some interesting things like that, which we're chalking up to here is a limitation to light LLM in general. So I started working on another tool called Oblit here that is a kind of an AI gateway as well. I'll share my GitHub page and you can check out this. But in general, being an HPC guy for so long, thought, why wouldn't we have something like fair share? So I've kind of added the fair share mechanism into that, and things like superpowers for individual LLMs. You can add things like vision to a model, so it checks the inbound as it's coming in to see if there's an image attached, and then it can actually send that off to another model to get the response back, so that the model you're working with, like in our case Minimax, knows exactly what the image was that you actually attached to it. So this is kind of what that dashboard looks like. So it's, very heavily, a lot of the things that I use inside of Light LLM, were kind of brought over to this as well. So if anybody's interested in this, like I said, it's on my GitHub page and you can check it out. We're not running in production yet, but we do have it on dev and it's been working really well. Again, more stuff about that, kind of just talking about the queuing versus, all the stuff we ran into on that. Going back to being a campus provider, so that was kind of one of the reasons that we had an issue with that previous user. When those spikes happened, I noticed this right away because I was trying to use our Slurm chatbot, and all of a sudden, the model wasn't responding because the queue was so backed out to 10 minutes, and all the requests were timing out for me. So that us being a campus provider providing local LLMs for campus, our campus chatbot, we can't have that happen. So we need to come up with a way to make sure that we don't starve out the campus chatbot by an API user, but we also don't want to limit the API user. They should be able to use all the available hardware that's not in use, as long as they're not kind of choking out the other users. So but yeah, so going back to that, we have a lot of research, users using this for integrated chat assistants or coding assistants. We have like our Slurm chat and other things like that. And our main big one here that's recently was announced was we're now a provider for Create AI Builder, which is our kind of campus-wide chatbot for integration with classes, and currently it's limited to faculty and staff, but we'll actually be opening that up using our backend to campus sometime here in the near future. And this is kind of what that project looks like. You can kind of come in here and set up a chatbot that then your students can then interact with directly. And this is a campus-wide tool. Yeah, so some of the things you're working on here, obviously we're looking at this, promoting that to production, growing campus-wide adoption. We're getting more people coming online, especially with the students, starting to get in to start using the campus-wide, campus available tools. They'll be, right now we're kind of research focused. Once we open this up to, the hundreds of thousands of students on campus, that's going to be interesting to see how it works. We're also coming up with some other cool agentic, multimodal research-specific workflows. So these are things that we're hosting. We have the capacity available. We have these Kubernetes hardware. So we're actually creating an interface to work with spinning up, research workflows directly in Kubernetes, outside of the AI piece specifically. We also have so we have some specific workloads or agentic and lab specific workloads that we're working on right now, and we're hoping to get out there a little bit more here very soon, and continuing to work on the Gaudi 2 piece in general. Like I said, the Gaudi 2, the hard part with this was just that it was, um, it's not NVIDIA. Everything's kind of built around NVIDIA. So, trying to get the Habana stuff to work with a lot of the code that users want to run it's been very interesting to say the least. So, and with that, that's kind of all I got there. There's a link to the GitHub page where I have, stuff that I put together lives. Yeah, if I did okay on time.
Oh, that was great. Thank you so much. These are both very interesting. And with that, we have a variety of questions. I tried to grab everything I saw in the chat, also put them in the call doc, so you all, put them where they fit in as far as questions go. Keep them coming. I'll start from the top, and I'll try to remember which ones went to which group, but consider them both questions for the both of you, right? So I believe this is back to Coltran. Does your H100 have NVLink? Was an
Yeah.
original question there.
Good question. Yes, our H100s do have NVLink, but we've run so some of our models do require running across multiple GPUs. We have run both on GPUs with NVLink and without. We've found that while NVLink slightly helps performance, it hasn't been critical for most of the models that we've run across multiple GPUs. So we do have that, not necessarily a requirement.
That. For you, Jonathan, while you set up your slides up, one of the questions was, if you wouldn't mind going back to that slide, why not Slurm HPC slide? I think that was like slide 8 or something.
This one here?
And I think so, yeah. And elaborate why it breaks and if it could work for a small departmental size cluster.
Yeah, so one thing we actually started playing with before we received the hardware, that we got in that donation, we actually looked at how we could use unutilized hardware. Because the nice thing with this is, you could spin up 10 instances of a model. And if, these are preemptible jobs on the cluster, they could get knocked out, and then a new cluster, a new one could spin up somewhere else. And you probably could make that work okay. It's just our cluster is extremely busy. There is, very little availability for any of our more modern GPUs. Our older cluster, we might have available, A100 or 1080s or like V100s or something, but those are relatively old at this point with small, amounts of memory on them. So yeah, for us, it just didn't really work well. If you do have a less used cluster, you could probably spin up something that, could play whack-a-mole across the cluster as some things get knocked out, spin them up to other places. And then you can actually just point to those, and that would probably work. But yeah, that was a hard one for us to do.
Thank you. And folks that ask questions, if there's any more elaboration or anything needed, please speak up. I would say both sides, how many people, FTEs, do you have on your team spinning up, provisioning, and supporting these resources and services? Maybe a better question is, what team roles are part of launching these services? And I'm
Yeah,
sure
so
that
on our side, we have our total research computing team is about 4 FTE in terms of staff, and then we have anywhere from 4 to 6 student employees as well. So pretty small team. I would say for this service, for running the back end and basic training of the service, it's about 1 FTE split across both sysadmins and some of our student employees. So not a huge uplift for us. There are some additional FTE outside of the research computing group involved in the support of the service. And so I would say overall, maybe about 2 FTE, 1 for the back end, 1 for the front end support, is what's actually utilized for supporting our service.
Yeah, and I would say ours is pretty similar. We have in research computing, our staff is about 6, and a lot of, about half is dedicated more on the software side, doing I guess I wouldn't really say software side anymore, but they're installing software on HPC system, doing working with researchers, things like that. And then a couple like three of us or so that work on the hardware side of things, or the architecture side, spinning up new services and things like this. So we also have a dedicated team for doing actual trainings and things. I mean, that's not part of our group. So, getting word out about the Gaudis and using API, that's, the engagement team, which they have, I think 3 or 4 people on that team now. We'd have some student workers under one of our groups that has been doing some testing with some of these pieces too. So yeah, I mean, we have quite a few people, I guess that have touched a lot of this across the, year or so that we've been working on it. But I would say for the most part, I mean, I've spent probably the last year of my life, kind of dedicated on this. So I would say I've spent a lot of time on this, being out of the data center, especially because the data center is about 50 miles from campus. So I've spent a lot of days out there working on, plugging in things and connecting stuff, and then spinning up, these different tools and things. So.
So just to make sure I'm understanding, I'm typing notes here in the background. You said 6 was sort of across the research computing enterprise, so to speak, but how many for this effort? You'd say about 1 to 2,
Yeah, I
similarly?
mean, I would say like 2 FTEs, working on this, a worth of time working
Yeah.
on this over the last year. So.
Yes, that's thank you. Thank you. And then back to Coltran, can you elaborate on how your VM makes requests to your Tempest HPC to run on perhaps dedicated compute nodes?
Yeah, so we have a mix. Our VLLM instances, those persistently running system or models for our primarily used models, those are on dedicated systems. So we essentially have a small number of nodes that are permanently in a Slurm reservation, and a service account that is able to use that reservation and run workloads within it. We essentially run a job on those that spins up the services for VLLM, and then dispatch out using that API. For the dynamically allocated ones, we basically have a pretty simple set of scripts that allow when Olama is detecting demand for a particular model, its API will trigger the script. That script submits a job into our cluster and starts up that model. So no custom Slurm integration for that, and we are using a mix of dedicated nodes and nodes that are generally available in our normal queues. We have a bit of an unusual access model that makes this work pretty well for us, in that we provide what we call absolute priority to a lot of our users that is not tied to particular nodes. So we have a bunch of nodes that depending on what they've purchased, different research groups have immediate access to whenever they want, up to a given set of resources that they've purchased. And so we essentially provide some of that priority access to to this service as well. And that allows it to reliably be able to spin up, allocate, and then deallocate resources as needed. There are other workloads that run on those, but those are preemptible. So we'll essentially preempt those workloads to allocate resources dynamically when needed.
Thank you. Then, Jonathan, can you comment on your level of usage trends, prior and future projections?
Yeah. So I would say over this last week has been a little slow. But the week before, I think we hit, 18 or 19 billion tokens used. And that was across, a handful of researchers doing work. I'm expecting that once we get the Create AI Builder opened up to students on campus, we're going to see that explode. Usage is probably going to go up exponentially. I think right now it's pretty limited in scope as far as who even knows about this tool. What's out there. It's very users who use our HPC system, which I think we have about 1,600 active users right now. They're the ones that see it. And then, at that point, it needs to be people who are interested in using a tool like this. So I think we have about 400 active API keys right now. And yeah, I mean, I see this once we open this up to campus, I see it really getting more use for sure. So I don't know what the numbers will look like there, but I'm expecting, hundreds of billions of tokens per week versus, tens of billions of tokens per week, which is what we're seeing right now.
And Coltran, I guess as far as kind of measuring trends and success, like are you measuring that by job submissions or
We're tracking utilization actually in the same way as Jonathan's
okay.
group. So we're doing token tracking. We also have a cost mapping of essentially we're calculating two sets of costs, both what it actually costs us in terms of just the resources we're using and the value of them. We also compare that to the cost it would take to run this if we were entirely using a cloud backend instead of an on-prem backend.
Great.
Yeah, we have those metrics too, the cost, kind of associated per key, which does cause a little bit of confusion sometimes with users thinking that that's going to cost them. But we've tried to make that as clear as possible that it's just for us internally to know how much we saved by using this service. So.
And then for other question, for student-facing applications, are either teams thinking about an additional governance or some sort of model usage layer?
I would say, with that one, through Create AI Builder, they do offer API access directly as well. So that was, kind of one thing that we were, initially looking at, but have started moving away from just because that tool does provide, kind of they have a huge team of people who have been working on making sure that that tool is safe for use, across student applications. Ours, we kind of still direct connection to our internal API there that we do provide for researchers. Doesn't have any guardrails on it. It's whichever models we have available, and it's meant kind of for research purposes. But for the broader community, when this gets used through Create AI Builder, it will have a lot of guardrails and policies and things like that in place. So we internally haven't had to think about that, but the other team has. But I think they have like 26 people dedicated on that team, kind of working on that tool. So.
Oh, that's great.
Yeah, and on our side, we actually make almost all features of this available to all of our faculty, staff, and students. Now, we're actually kind of similar to Jonathan's team. We're in sort of what we call a soft launch phase. It is technically available to our entire campus. We have let word spread by word of mouth to some extent. This fall, we're planning a full broad campus-wide announcement, so we expect pretty drastic uptick in adoption there. We are we do implement guardrails on all of our models, or at least to the extent to which the models support it.
Mhm.
We also do have a data, basically a use agreement that ties in with our standard campus policies that students, faculty, and staff already adhere to as part of either being admitted or agree to as part of either being admitted or employed by the university. So we're largely leveraging that regulatory framework. We do provide some pretty extensive guidance in terms of types of data that are and are not allowed, in what cases we would provide information if there's a acceptable, like an academic integrity inquiry, et cetera. So we really didn't create any new policy for this, but we did build out some documentation around how campus policies apply to this service.
Thank you. Or say we might have time for two more questions. Thank you so much, everyone, for your submissions and the panelists for presentations. I saw you're using VLLM as the inference serving engine. I was wondering if you also considered TensorRT LLM for serving. If so, what made you choose VLLM over TensorRT?
I we did look at a couple of the different I'm spacing on the name of the other one that we looked at as well. But initially we were using VLM across on the cluster in general, so it was kind of just fit. And now I'm very happy that we kind of went down that path, just because VLM actually has put a lot of the VLM community has put a lot of effort into making sure that the Gaudi plugin is really up to date, and they're trying to keep up with the latest releases and things. So the nice thing about like AI Bricks, for example, SGLang, that was the other one I was thinking of. So AI Bricks does work with other providers too, and AI Bricks is kind of the router that we use to send requests to the correct models in the back end. So I mean, if we found a model that worked with that one, versus what we're using, I think we could spin that up fine and it would just work. Yeah, no reason to use it other than that's what we had, and they have pretty good support for the hardware that we have available.
Thank you.
Similar on our side. I mean, we did evaluate several options. I'm not going to go into the technical details there, but overall, for the persistent models, VLLM was generally for us the most supported mature platform for what we were trying to do. But there were other platforms that also absolutely would have worked.
Let's see, both presenters mentioned creating their own user account and API creation portals. Was that done to avoid paying for a light LLM enterprise?
Well, on our side, this was something that we've already been trying to get our users in and using. So our portal is very self-service on the side of HPC side. So users can come in now and request accounts, and the PIs get notified. They can approve accounts. So we kind of already started moving down that self-service route, and just tying into another API to grab and create keys just seemed like it made sense. So for us, it was just more of a convenience thing. And like I said, in the future, a lot of users will probably get their API keys through Create AI Builder, which sits in front, will sit in front of us. So yeah, I mean, it was more so just we already had the tool, and it kind of fit our design. So that's why we went with that direction.
Yeah, and I think the fairly similar on our side. I think there was another part of that question around expiration of keys. Yeah.
Mhm.
And so for us, the generation of keys is behind SSO. Once you have the API key, that key is your authentication. And so that's why we needed expiration on those keys, is because you don't have to re-authenticate with SSO every time you're using the key, just when you're generating it.
Yep. Yeah, and ours is like our UI, we use in Commons, you log in, and yeah, you create the key in there and it's tied to your account. So we can keep track of the actual tracking. Yeah, you don't have to run in and into the UI, or we don't even have to share out the light LLM UI to users as well. So I don't know if any of that stuff I didn't look at permissions at all inside that UI, but yeah, in general, just keeping that piece hidden so people can't even try to access the thing, I think was one of our for security reasons as well. So,
Johnathan, with integration into research security workflows, how are your researchers managing reproducibility?
that's a good question. Yeah, I'm not 100% sure on that. Like I said, I'm more on the technical, architecture side versus working directly with the researchers. But I can probably find somebody to get you in touch with if you're interested in that. That maybe one of the researchers or one of the people on one of those teams that might have an answer to that question. So.
Sounds like a great collaboration with the data facing group too. Maybe we'll do a group call. Where are in Coltran, anything on that one for groups?
I'll just say, yeah, I mean, I think we've had a number of discussions around this with this and other services, particularly with our data librarians. Reproducibility when working with generative AI is a huge challenge, and I don't think it is a solved challenge. Some of the tools that we've used in terms of being able to do some of the mind mapping and track processes help with that. But it is very difficult to truly get a reproducible workflow that includes a generative AI component, regardless of platform, from what we've seen.
No, that's great. Where are outreach, teaching, support folks organized in the campus? Do they support other topic services than beyond those operated by what you call the RCD group? I feel like this is for Johnathan, potentially, with your training and engagement mention.
Yeah, so I mean, that group is, I guess, parallel to us. So we do work with them quite closely. They do a lot of our trainings and things like that for our HPC, usage as well. So when students, we host all kinds of workshops for things. AI workshops more recently. We have like GPU Day, which is like a thing where like NVIDIA or one of the big providers comes in and does like some workshops there. So in general, we do trainings. Trying to any interesting subject. Things that people are trying. Anything that anybody could be interested in. We try to, if we have an expert, kind of putting those together. We also do like workshops where we bring in researchers who want to talk about a subject that they have been working on. And yeah, just our general trainings are usually focused around things like Python or using the HPC system, kind of for new people as they come on and start using the HPC system. So
And that's a group outside of RCD, you're saying?
it's a group outside of
I think
it's
that's
a
what's
research
throwing me off.
engagement.
Yeah.
Yeah, research
Okay.
engagement group.
Okay.
So that's it's outside of us. So they I think have like four, I believe four people that kind of run that group now, or they're in that group.
Well, with that, I do apologize. I think there's two questions we didn't quite get to, but hopefully we'll all be participants in future researcher-facing sessions, and we'll be able to bring it up in next month's call. So a quick shameless plug: if you haven't seen the call doc, feel free to sign in if you haven't. I put a lot of the questions in the notes that we could capture. Thank you so much, Calvin and others on the steering committee for your help, and also thank you so much to our presenters, Coltran and Johnathan, for presenting today.